Until now, we have seen data preparation, converting non-numerical data into text data, non-numerical text data into numerical data, because the text data cannot be analyzed directly. Now we are going to do something called sentiment analysis. Have you ever heard of sentiment analysis? What is sentiment analysis? This is one of the most widely used application on text data. What is it? It is also known as opinion mining, sentiment mining, verbatim analysis, subjectivity detection, whatever it is. What it tries to tell us is given a review, whether it is positive or given a review, whether it is negative. That's what this sentiment analysis is going to tell us. As we know that text data has some limitations, we cannot directly use it to do the analysis. We have to convert the text documents into numerical data. What is this numerical form called? This numerical form is known as
DT.
document term matrix. Then you can do sentiment analysis on top of it. So let us take the text data only and we will execute until the point that we have executed previously. Once we have the document term matrix, then we can go ahead. So let's go to the second piece of code, which is sentiment analysis code that is there in our classroom itself. If anyone has opened the code directly, keep it in the chat window. I'll try to click on it. Otherwise, you can go to this one. So somebody has pasted the code here, code link. Let me go there directly. The previous steps, usually a lot of people don't care about data pre-processing because there is a pre-processing function that will be present almost in every company. So they just apply this pre-processing function. But if you're working on a data set from the scratch, completely from the beginning, if you're working, you must know the pre-processing as well. Then we created a word cloud to get an idea. Then we created a document term matrix, which is the actual numerical equivalent of our text data. These things we already discussed from past 2 hours. We have been discussing that only. Now let us get into the concept of sentiment analysis. So keep it for execution, let it execute in the background. It keeps on executing. Then we will discuss the sentiment analysis algorithm. We're going to use a different machine learning algorithm here because once you have the numerical data, you can apply logistic regression or decision tree or random forest or boosting. But the problem is there are too many zeros here. Document term matrix is very sparse. That's the reason why these algorithms may not work effectively. A different probability based algorithm works very much effectively. It is known as naive Bayes model. Naive Bayes machine learning algorithm is a new algorithm that we are going to discuss. Once again, a different algorithm we are discussing. This works perfectly even on sparse data because it works on probabilities rather than the actual values. Naive Bayes model comes from a theorem called Bayes theorem. Probability of A given B is equal to probability of B given A into probability of A divided by probability of B. This is known as Bayes theorem. When you see this Bayes theorem, it looks so confusing. It looks so complex, but you will be surprised to know it is so simple. Once we understand this, it looks so easy. Because of the terminology, it looks very complex. Let us make this Bayes theorem easy to understand. Let us take one example to understand this Bayes theorem. Imagine there is a factory. In that factory, nuts and bolts are developed or nuts and bolts are produced so that they can be used in an aeroplane or somewhere. That factory produces nuts and bolts that are used in aeroplanes. That factory has two machines, machine A1, machine A2. Machine A1 produces 60% of the nuts and bolts. Machine A2 produces 40%. Machine A1 produces 60%, machine A2 produces 40%. Okay, A1, A2. Machine A1 has a defect rate of 1%. What do you mean by defect rate? What do you mean by defect when you are producing nuts and bolts? Since these nuts and bolts are used in aeroplanes, even 1 millimeter difference, if there is a issue, even if one of the bolt is cut 1 millimeter higher than it should be, then also it's a defective. So machine A1 has 1% defect rate. Defect is given by denoted by B. Machine A1 has 1% defect rate. Machine A2 has, again, defect is denoted by B. Machine A2 has 5% defect rate. So that is in probabilistic terms, you will say probability B given A1. Given A1, the probability changes 1%. Given the machine, probability of defect, given the machine is A2, does the probability change? Tell me. Probability of defect given the machine is A1. Probability of defect. This is also probability of defect only. But the first one is probability of defect machine. Given the machine is A1, what is the probability? Given the machine is A1, what is the probability of defect? Given some prior information, this probability is how much? 1%. Probability of defect only, but the prior information is given the machine is A2. What is the probability? Given the machine is A2, the probability is 5%, 0.05. Let's say if you want to understand this concept of given, let's take one more example. Given any day, what's the probability that it is Saturday? Take any day. What is the probability that it is Saturday? When you're thinking probability, first write down denominator, then think of numerator. All cases are how many? All cases are 7. Favorable cases are how many for Saturday? 1/7. Is that right? Probability of Saturday is 1 by. Probability of same Saturday, given it's a weekend. I told you, you know what? This is a weekend. Can you now tell me the probability of Saturday? मैंने आपको कुछ prior information दिया. Is it still 1/7 or does it change now with the prior information? Will it be still 1/7? No, it will change. Given the prior information, now it will change 1/2. What is the probability that it is Saturday? Given yesterday was a Friday. मैंने बोला कि कल Friday है. What is the probability of Saturday? अगर कल Friday है, if yesterday was Friday, what's the probability of Saturday? It has to be 1/1, isn't it? So do you agree? Given the prior information, the probability changes. Have you understood given, the concept of given? Is it very clear to you, all of you? This notation, probability of an event given prior event, given the prior event, the probability changes. Does it make sense to you, all of you? Now, what is the overall defect rate? If I want to know the overall defect rate, overall defect rate is how much? Can I simply add 1% plus 5%? Overall defect rate is 6%. Does it make sense? Can I simply say 1% for 5%? Overall defect rate is 6%. Does it work like that? No, because A1 produces 60%, A2 produces 40%. They are different. You have to give the weightage. So A1 defect rate into A1 production rate. A2 defect rate into A2 production rate. A1 defect rate into A1 defect rate into A1 production rate. Look at this, all of you. A1 defect rate into A1 production rate. Does this term make sense to you? Plus A2 defect rate into A2 production rate. Is this very clear? It has to be crystal clear to you. A1 defect rate into A1 production plus A2 defect rate into A2 production. 1% into 60%, 5% into 40%. The overall defect rate is 2.6%. It is not 6%, it is 2.6% is the overall defect rate. How this 2.6% is arrived? Is it very clear to you? Yeah, 2.6% percentage and the production is multiple. So the overall defect rate here is 0.026, which is like 2.6%. That is how the regular probability flows. The regular probability goes from your left hand side to right hand side. Machine production rate, production probability. Given the machine, what is the defect rate? Machine A2 production probability. Given the machine, what is the defect rate? The regular probability goes from left hand side to right hand side. But this guy Bayes theorem or Bayes probability, it is known as inverse probability theorem. It goes from right hand side to left hand side this way. It is ulta, because the regular probability, all of us, we can count it very easily, isn't it? Favorable cases in the denominator, favorable cases in the numerator, all cases in the denominator. That's the regular probability. Bayes theorem goes from this side to this side. Let me give you an example. Let's say you are a quality check inspector and you got a huge heap of nuts and bolts in front of you. There's a huge heap of nuts and bolts. Okay. Now from that heap, you took one product, maybe a small nut is what you have taken, or a bolt. Okay. And this is defective. Already you're saying this is defective. You found it to be defective. Given this is defective, defective means we are denoting defective. Can you backtrack and find out? Given this is defective, can you backtrack and find out? Tell me, what does Bayes theorem will tell us? Can you backtrack and find out the probability that it was produced by machine A1 or machine A2? Given this is defective, Bayes theorem will tell us, can you backtrack and find out whether it is coming from machine A1 or whether it is coming from machine A2? With a simple trick, we can find out that probability. That is Bayes theorem. What is that simple trick? Let us see here. Overall defect rate denoted by probability of B is equal to A1 contribution plus A2 contribution. What do you mean by A1 contribution? A1 defect into A1 production. A2 defect into A2 production. Is this formula very much clear to you? Overall defect, A1 contribution, A2 contribution. But in this Bayes theorem scenario, here I'm saying this is already defective. Probability of B, already I'm saying this is defective. If I give you a sure shot event, I told you today is Saturday, and I asked you what is the probability of Saturday. What will be your answer? I told you today is Saturday. Then I asked you what is the probability of Saturday. For a sure shot event, what will be the probability? Probability is 1. So already we told this is defective. This is already 1. This side we have to make it 1. How do you make this side 1? Divide this by probability of B, this by probability of B, this by probability of B. So 1 is equal to A1 contribution, which is probability B given A1 into probability of A1 divided by probability of B plus A2 contribution. What is it? Probability of B given A2 into probability of A2 divided by probability of B. This is A1 contribution. This is A2 contribution in this overall defect. If an element is defective, what is the probability that it is coming from A1? This is this much. What is the probability that it is coming from A2? That is this much. This formula is nothing but Bayes theorem formula that you have seen actually. So this side you have to make it 1, divide both the sides by probability of B. This is the Bayes theorem probability. Probability of AI given B is equal to probability of B given AI into probability of AI divided by probability of B. That is the Bayes theorem. Obviously, we don't need to memorize everything, but we need to understand how that theorem came up. So out of overall, this much is the A1 contribution, AI. Out of overall, this much is the A2 contribution. That's what this Bayes theorem will tell us. But how do you connect this whole Bayes theorem to our context? Our context is not really nuts and bolts here. What is our context? What is our objective? Given a review, I want to know whether it is positive or negative or not. So you can understand this way. How do you connect that to actual concept here? Look at this carefully. Imagine a machine A1, that is producing all the positive reviews. Every review, every document that is coming out of A1 is positive, 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 positive. Everything is positive. Imagine machine A2, that is producing only negative reviews. Negative, 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 negative. Everything that is coming out of A2 is negative. Everything that is coming out of A2 is negative. Okay. Now imagine a new document. In front of you, there is a new review. When you read that review, let this review be document D. This is new document D. Given this document, given these sentences, given these words, can you backtrack? Can you backtrack and tell me using Bayes theorem? Given this document D, can you backtrack and tell me the probability that it is coming from either A1 or the probability that it is coming from or A2? Given these words, given these sentences, can you backtrack and tell me, is it mostly generated by A1 machine or is it mostly generated by A2 machine? Maybe there's a chance that it is generated by A2 as well as A1, but which one has higher probability? There's a 90% chance that A1 has produced it, only 10% chance that A2 has produced it. Then I would say this is a positive review. Otherwise, I'll say negative review. Given D, document D, this is document. Whether it is coming from class 1 or class 2, that is this Bayes theorem. To make it very simple, let us take one document which is very, very simple document. Somebody wrote a very short review. Somebody wrote the document. In the document, he simply wrote good. That's it. That's the review. बस इतना ही लिखा था. Good. How is the movie? Good. ज़्यादा कुछ बोला नहीं. That's the document. That's it. Now we know that this is definitely what kind of review? Tell me. We know that this is a positive review. But how Bayes theorem works in the back end? Here are the formulas that Bayes theorem works. Probability that it is coming from positive. Given good. Given good. What is the probability that it is coming from positive? Given good. What is the probability that it is coming from negative? That probability is also there. So out of all good, how many times good appeared in positive into positive? So this formula will be. Let us see how these calculations work. Look at this, all of you, carefully. Let us suppose overall there are 8582 positive. In fact, we are checking that in the real data itself, in our own data, there are 8582 positive tweets are there. 7781 negative tweets are there. Is it possible that the word good will appear in all these tweets? Is it possible? Do you think the word good is appearing in all these 8582 as well as 7781 tweets? Not necessarily. So if you check, good has appeared in positive tweets 1218 times, 1218 times. Good will appear only in positive tweets or can it appear in negative tweets as well? Is there a possibility? Is there a possibility that good has appeared in negative tweets as well? Possibility is there.
Yes.
Yes. So negative tweets maybe appear 231 times. Let us find the probabilities now. Bayes theorem, how does it work? First of all, find the overall probability of positive. Probability of positive. Tell me based on these numbers, can you tell me probability of positive? When you're thinking of probabilities, first think of denominator, overall cases. Then think of numerator, which is favorable cases. Denominator में बताओ. What is the expression that I write here? Denominator, probability of positive. Given any tweet, what's the probability that it is positive? Overall cases कितना है? Overall tweets कितना है आपके पास? 8582 plus
7781.
Does that make sense, all of you? Is that the overall cases? In the numerator, what are you going to write?
8582.
Favorable cases. Look at this, all of you. Does that make sense to you or not? What is the probability of negative? Again, tell me the denominator. Denominator क्या है?
2 plus 7781.
What is the numerator?
7781.
7. Probability of good given positive. Already मैंने positive दे दिया. Then in that case, what will be the denominator?
8582.
8582. How many times good has appeared in positive? How many times good has appeared in positive? What is the numerator here?
1218.
1218. Given negative. Denominator will be
7781.
7781. What will be the numerator?
231.
231. What is the probability of overall good? I don't care whether it is positive or negative. I don't care what type of tweet it is. Overall good. Overall, what is the probability of good appearing? So denominator will be overall cases. Overall cases कितना है denominator? Overall tweets.
218.
Okay. Then numerator में कितना आएगा? What are the favorable? Do you like to change that opinion? Think about it. What will be the denominator?
Yes, that should be numerator.
Yeah. So tell me the denominator first. Overall good. I don't care positive or negative. Previously you told given positive, you told me good. Given
Okay,
negative, you told me good. Now don't give anything. Full data. Full data means what?
8582 plus
8582 plus 7781. And how many times good has appeared in the overall data? Favorable cases कितना है? 231 plus
1218.
Does that make sense? You have to think a little bit carefully here. Then we will realize this is the answer. Now probability of good is there. Probability of good given positive is there. Probability of positive is there. You can substitute them. Probability of good is there. Probability of good given negative is there. Probability of negative is there. You can substitute them. When you substitute all these numbers, in fact, these calculations will happen in the back end. When you substitute all these, probability of this particular one being positive will be 84%, 84 point something, and 16% will be probability of being negative. So obviously, if somebody writes simply good, these calculations will happen in the back end. What will be the result? Bayes theorem will tell you this document is actually what kind of document? The sentiment is
good,
positive. Positive sentiment.
positive or negative.
This is for one word, but in reality, do you have one word or multiple words? The movie
Multiples.
was pretty good. I enjoyed a lot. Word 1, word 2, and so on. Then the extended formula for this is here. It is only word 1. Probability of positive given word 1, word 2, word 3, and so on. This is the extended formula, which looks like exactly the same way. The calculations are happening exactly the same way. Probability of negative given word 1, word 2, word 3, and so on. This formula. Finally, this formula will be applied in the back end. This is the original formula for Bayes theorem. So Bayes model gives us the positive or negative sentiment of a given document by using this whole calculations. We don't get to see them. We don't get to modify any of these. These calculations will happen automatically. You will just simply give the data just like any other machine learning model. You prepare the data X and Y, train data, test data, then use this function called multinomial Bayes model. Finally, it will give you the output. Usually, a little bit of overfitting is observed. The difference between train and test data will be slightly higher. The reason is we are working with actual numerical data, actual text data, which is converted into numerical data. So it is very difficult to observe the same pattern in train data, same words being used in test data. When it goes to numerical data, train and test data will have generally the same distribution. But the number of words, the kind of words that are used in train data are not same as the kind of words that are used in test data. A little bit of overfitting is observed and that is accepted in test data in the text mining. The model is built and you can actually get the output for this model. This model will be able to predict the target variable. Looks like there is some error. That's fine. Now what we will do is we'll go ahead and try to have a look at the data. In our data set, there is already one column called sentiment label. By the way, you have the data set with sentiment label in it. Already sentiment is given. Why are we building a model then? Sentiment is given, no? आपके पास sentiment है तो model का क्या जरूरत है? Think about it. Are we really building the model to find the sentiment of this data set?
Future.
future, for new document. That's the whole point of machine learning, isn't it? Learn the patterns from the existing data, apply it on the future data set. So build the model on this and then try to make the prediction on the new data set. So usually one of the suggestion that I tend to give is you have to create this document matrix. Is this working? Text columns clean. Looks like this pre-processing is what we have missed. So what I have missed, you might have executed that. Pre-processing will happen. After that, I'm taking this Twitter data and sentiment. So usually you have positive sentiment, negative sentiment, and here in our data set, neutral sentiment is also given. This neutral sentiment, that means people have some opinion, but they are neither positive nor negative. It's a good plan to convert this neutral sentiment into negative sentiment. If you are very strict that you don't want to accept even neutrals, even somebody says I'm neutral about it, you can consider that as negative because they don't want to be bad. Or sometimes if you're giving some free services, even somebody saying neutral, you can consider that as positive. Otherwise, if you are unsure, you can simply ignore neutral. But do not keep neutral as a separate category. It will be confusing the machine learning model. Either add neutral to negative if you want to give very, very good services, if you are very strict about your rules. Give neutral to positive if you are giving free services. Otherwise, ignore neutral. In my case, I'm ignoring neutral. I'm keeping everything else. Okay. Let us see. For me, that pre-processing is going on in the backend. So for you, you must be getting the output. Execute this, remove the neutral ones, and then try to execute the code where it will break the data into train data, test data. And this is the code for multinomial naive Bayes model. You will get train accuracy, test accuracy. On the test data, you can get the predicted values. On the test data, when you go for prediction, you will get positive, negative, positive, negative. But that's not what we are building the model for. For this, already we have the sentiment. This is the reason where we are building the model for. Awesome experience. Go for it. It's a great place. Let's say somebody has given this new tweet. Somebody has just tweeted. You're done with model building. Somebody has tweeted this. Awesome experience. Go for it. It's a great place. Very bad day for me. I would like to forget it as soon as possible. Now we need to tell the sentiment for these two tweets. Let's take one tweet. Do you think our sentiment analysis model, naive Bayes model, was it built on text data? Was it built on text data? Tell me. Have we built our model on the text data? No, we
No.
took the text
Yeah,
data, converted that into what kind of
DTM.
format? What is this called?
DTM.
TTM. Do you think if you give this directly as input, do you think the model will be able to make a prediction? Do you think on this tweet, can the model make a prediction? On this tweet, can the model make a prediction? No, the
No.
model won't work on this. What you need to do? You need to convert that tweet into DTM format. What do you mean by converting that one tweet into DTM format? Tweet one. This is your document of matrix. Yes or no? 3000 or 4000 columns are there. Inside your document of matrix, somewhere awesome will be there. There it will be one. Everything else will be 0, 0, 0, 0. Somewhere experience will be there. That will be one. Everything else will be 0, 0, 0. Somewhere grade is there. That will be one. Everything else will be 0, 0, 0. Somewhere place is there. Do you think the model can work on this particular row now? Can I-based model give you the result on this one? Can it understand this type of format as input? Yes, it can understand. Similarly, if you are giving this one directly, you cannot give. Tweet 2 need to be converted to document of matrix. Somewhere very will be there. That will be 1. Remaining all will be 0. Somewhere bad will be there. That will be 1. Somewhere today will be there. That will be 1. So wherever these words are appearing, that will be 1. Everything else will be 0. This naive model understands and gives you the output. If there are any new words, the model will throw an error. If there are any new words, the model will be throwing an error. What we need to do is you have built the model on 3000 words or 3000 or 5000 words vocabulary. If there are any new words coming, you have to identify them and remove them. So I have given the code that will identify the new words, make sure that the new DTM and old DTM, let's say this is a new DTM, document of matrix, which has 2 rows and 3015 columns. Old DTM also has 3015 columns only. There should not be more columns in this new data. If there are more columns, that means we are giving new words. Those new words need to be deleted because you built the model with 10 variables. You cannot make a prediction with 11 variables. You have to ignore that 11th variable. You have to give 10 variables only. Similarly, by building the model itself, take the rich data, cover everything, full vocabulary, and ignore the new words. And once you submit the first tweet, the prediction will be positive. Second tweet, the prediction will be negative. That is how the sentiment analysis works. Once again, take the data set, and then what I'm saying is if you have positive, negative, neutral here, whenever it is neutral, I'm just ignoring that. ETM versus V1 not defined. Again, I got an error, is it? Let us see. This one is Twitter data and then document of matrix. Yeah, document of matrix created now. And then from the document of matrix, now I'm getting the target variable here, attaching it to the document of matrix, create the train and test data, build the naive model, have a look at the accuracy. Usually text related models are slightly overfitted because in numerical data, we expect the same distribution in train and test data, but in the text data, we cannot expect the same words being repeated in train and test data with the same distribution. That's impossible. That is why a little bit of overfitting is fine. And this is on the test data, we got the predictions, but we are not interested in such predictions. We want to apply this model on a new data set. By applying this model, you will get the prediction, but directly you cannot apply the model on a sentence or on a tweet like this. You have to convert it into document matrix format. It will be a 2 cross some, how many other columns are here? It will be a 2 cross 3 4 7 1. That will be the shape of the new document term matrix. Make sure that there are no new words. This much of code is not required, but to be on the safe side, I'm checking all the new words if there are any new words. So 2 cross 3 4 7 1 is the new document term matrix shape. This is a previous document term, the train data document term matrix shape. And then the final result will look like this. Awesome experience. Go for it. It's a great place. There are usually 3 types of data sets that you tend to see. 3 types of data sets. One is social media data, Twitter data, Twitter sentiment, Facebook or comments or something. The other data set is product review data. What is the other data set? Services review data. Don't you think these are the most prominently used sentiment analysis scenarios? Either your company has a product, lot of reviews you are getting, or your company is providing some services, you're getting a lot of reviews, or people are talking about your company on social media or your product on social media. This one we just covered now. If you want to really practice the same technique or scenarios on product review data, I'm providing you the Amazon product review data set as a practice or a homework. You can use it. If you want to practice on service review data, Yelp is a service provider, something like Urban Clap in India. Yelp, where people provide a lot of services. That is service review data. Once you cover these 3, almost the complete sentiment analysis is covered. Okay. So you can practice the same techniques on the extra data set as well. Okay. This one is sufficient, but if you want to do a little bit of more, if you want to add something else, then you can do on this as well. That is the story of sentiment analysis. I want to tell you something. Where is this sentiment analysis or NLP is used? Which industry it is used? Is it used only in banking industry? Is it used only in e-commerce industry? Is it is only in hospitality? Is it used only in healthcare? Is it confined to only one particular industry, or in any industry where the text data, anybody who is getting the reviews, anybody, anywhere you can use it? It's in any industry. So no matter which industry, no matter which background you are from, can you simply put a sentiment analysis project on your CV? Let's say if you are from banking background, maybe you may not be able to put an e-commerce project on your CV. If you are from e-commerce background, maybe you cannot put a banking project on your CV. But whether you're from banking or e-commerce, can you put a sentiment analysis project on your CV? Is it accepted? So this is an easy target. It's a low hanging fruit. All of you understand this NLP pre-processing process, understand sentiment analysis, do the same thing, simply create a story. Simply create a story of some sentiment analysis. You can keep it in your CV. You will have a ready-made project. Okay, you can simply say sentiment analysis. Usually the interview questions that you get related to sentiment analysis are mostly on pre-processing only. No more than sentiment analysis. What are the steps of pre-processing? If you can explain those steps of pre-processing. In a couple of interviews, it happened with our old students that they got these questions in the interview. They did very well. They have explained. Actually, in the outside industry, a lot of people are not following the step-by-step process that we discussed here. So if you could explain all the step-by-step process, all the steps of pre-processing the text data, then there's a high chance that you can crack that interview. Okay. So I request all of you, either some of you might work with the Twitter data itself, some of you may want to take Amazon data or Help data, something or the other, take it, practice it very well, and put a project. You must put a project on sentiment analysis, okay, or emotion detection. You can change the name, you can slightly tweak it, modify it, but include a project on sentiment analysis, no matter which background you are from, isn't it? Nobody can question you that whether you really worked on the text data as well. Okay?